Okay, on the sheet that we worked on, they show us there are 6 different crystal shapes. And so I have these kind of organized by those same crystal shapes. That was one of the questions on the back here. A lot of you forgot to read the half sheet here and look at the pictures that went along with it. It would make your work a lot easier. One of the things it says is that there's a cubic shape, and so that's the first one. Some of you called that isometric if you Googled it instead of reading the reading. So it's similar. Isometric has some other things included. So all of these things on this end have a cubic shape. One of them is galena, which is really, really heavy, and it's very brittle. We have some tiny little crystals of galena that I will show you magnified. Diamonds are something that in the wild would have more of a cubic shape before they are shaped by the jewelers. The bismuth crystal that we like to look at in the room that has a really cool design to it, as well as all of these salts. You can see the shape in this, and some of you are looking at that thinking it looks more like a rectangle than a square. If I were to drop this and it were to bust into little pieces, it would bust into a bunch of tiny little squares. If you remember looking at salt through the microscope when we studied microscopes in school, you might even be able to see that in your own salt shaker if you have a magnifying glass. There's fool's gold. If the fool's gold cools down slowly, then you end up with, fool's gold is pyrite, you end up with small crystals of pyrite. If it took a good long while to form, then you end up with much bigger, really nice cubic shapes. So that's a lot of fun. Here, this purple one is fluorite that came out of a stone quarry in Ohio that Miss Kaufman and I got to go to. Our friends were finding the iridescent fluorite, beautiful little cubes, and I will magnify those for you. Another cubic one are these that I got from that auction that I went to. Oops, I was meant to hold on my white card. Remember this phantom one that you can see through? This is potassium, aluminum, chromate, sulfate, and these other ones are fluorites. And a professor friend of mine, Ron Fabish, and his students made those in their lab. You can look on YouTube to find out how to do that if you have access to chemicals. The next one on your list says tetragonal, and it says nickel sulfate, and thanks to Ron Fabish, I do have some nickel sulfate that they created in the lab. Has that rectangular shape. This next one says that it is orthorhombic, and they said sulfur. My sulfur doesn't have a lot of crystals to it. It almost looks like scrambled eggs. It almost looks fake. When I first saw this in rock collections, I didn't think it was real, but that is what it looks like. This is what's in matches. You might have smelled this rock before, and it smells like a burnt match. You can see a little bit of the crystal shape in the picture of it from the periodic table. This is one that I bought when I was with some other rock collectors, and when I look at that, I see a hexagon. So I wanted to put it in the hexagonal shape. But this is aragonite, and it is in the orthorhombic because if you were to hit this, it would bust in the middle and would break into these little shapes. So it can be a little bit deceiving. That's why we have so many different other ways to help us identify what we are looking at. All of these right here are monoclinic. It says gypsum, and so we have some gypsum here. Really nice shape, just like the one on your paper, that parallelogram. Here's some other gypsum that's in like fine little feathery things. That's really pretty. This is our borax crystals, and they make a monoclinic shape. This is a favorite crystal of mine. This one is, I always read the name of it. This is selenite, and selenite crystals. That's what was at the very first page of our book. Those were selenite crystals down in Mexico. These were given to me by a friend of mine from their travels out west. Let's see, copper sulfate is the next one, is triclinic. And so if you look at the end of it, it kind of looks like it has a little parallelogram on the end there. I'm sorry, a little trapezoid shape. That's why they don't let me teach math. It's a trapezoid shape. And so we have a really nice copper sulfate that Ron Fabish's students made for us to look at. And they also made a potassium ferrocyanide, which has the same shape, but it has a different color. And hexagonal, I have lots of quartz because it is, as it says in our reading here, it says that quartz is the most common of all minerals. It's made of silicon and oxygen, and its crystal forms are varied in form, aspect, and color. You can see I've got a lot of different kinds here. We have these different colors. We have the purple, which is amethyst. We have the clear. Here's some pink rose quartz, some white milky quartz. This one is smoky quartz. There's also an orange one called citrine that I don't have. So it comes in a variety of colors. Sometimes you see that someone has taken a geode like this one, where there was a hollow spot in the middle, and in that hollow, undisturbed spot there, crystals grew. These are something that a lot of people find in Tennessee. I've never found one, but this is a really nice one on the outside. They kind of look like a brain or like cauliflower. Kind of gives you a clue that on the inside you are looking for a geode. They're never smooth. They always have that brain or cauliflower look to the outside. And so someone found one and they sliced it to make these, and then they dyed it blue. So when you see these, that's not a natural color. That's a dye that they've put on there. But they have that nice hexagonal shape if you made of the little paper things that I sent to you guys. Another hexagonal one is sugar. I think you might buy these little things. Now this one is not necessarily a mineral because it's organic. It's made by a plant. Sugar comes from sugar beets or sugar cane or maple syrup or corn syrup, a lot of different places. The one that I have in here, I'm protecting it because this one's a lot of fun. My mom actually grew this one accidentally in our Dayquil. So when you want to grow a big crystal, if you start with a tiny crystal and you drop it in solution, then the rest of the crystals will form on it and it will grow bigger. She had some Dayquil that she got out of the back of the medicine cabinet, and sugar had crystallized around the outside, and when she closed it up the last time she used it, a little tiny crystal fell down inside of the Dayquil, and then it grew because nobody touched it for months and months. So when she got it out, there is a perfectly formed hexagonal sugar crystal with a little hint of orange from our Dayquil. So that was kind of fun. So one of the ways that we're going to identify minerals is to look at their crystal shape. It gives us some clues as to what it may be. If I find something that is clear and it is a cube, I know it's not quartz. Then I'm going to go down there and compare it to those. So sometimes when kids have these rocks that are neat in their collections that have been all polished and they're beautiful and they're smooth and it's kind of satisfying to hold them and to make jewelry out of them, but sometimes people bring me this and say, what is it? Well, without the crystal shape, one of my clues is gone, and that makes it a lot harder for me to identify. It could be jasper, could be agate, could be flint. I'm not really sure. What do you think, Benny? What do you think that is? So I hope you learned something about crystals, and I hope you like seeing the collection. This is my collection of lab-grown crystals that I won at the science conference this year. The Earth Science Teachers Association has a rock raffle every year, and I was very excited to win these. They were grown by my friend Ron Fabish, who is president of the Earth Science Teachers Association. He grew these with his students. I'm not sure if they were the students he worked with at Brunswick High School, where he taught for years, or when he was working at John Carroll University or Miami University. What we see on the left, 2 columns, are fluorite crystals. They can be white or green or purple. A couple of those I would like to take out of the mineral oil that they are suspended in right now and prepare those again so we can see them a little bit better. They're suspended in the mineral oil to keep them from oxidizing or to keep them from absorbing moisture and dissolving, because some of these crystals are water soluble, and those two, there's 2 of them over there haven't really stood the test of time. The beautiful green ones in the middle are the nickel sulfate, and the next one is the red ones are potassium ferrocyanide, And then over on the right side, the gorgeous blue one is copper sulfate. Many of you have this at your house if you have a farm pond that you spray copper sulfate in to keep the green stuff down. It crystallizes very beautifully like that. And the last one there on the top, that one's a phantom crystal. If you can see, there's a crystal inside of a crystal. Purple one in the middle, the outside one's more see-through. And that one is potassium chromate aluminum sulfate. I believe. Well, no, is that it? Yes, that is right. I just love them. I was very excited to win them. My friend gave me this great magnifier with a light on it so that we can look at very small crystals. These are sugar crystals, so you should be seeing some long hexagonal crystals in there as opposed to the salt crystals. Where's my salt pile? There's the salt pile. The salt has tiny little cubes. We looked at that through the microscope in class. We were learning about microscopes. Over here we have some of the tiny little pieces of the galena that have popped off. It is a very brittle mineral and it has tons of tiny little cubes that it's made out of. This is the bismuth. Bismuth is amazing. It makes some very unreal science fiction looking kind of beautiful crystals. You can watch YouTube videos about how to make your own bismuth crystals, but it is dangerous. You have to buy an ingot of bismuth and you have to melt it down in a pan that you are not attached to because it's never going to come clean again. And you have to heat it up to about 500 degrees. And as it cools down, you do get some of these crystals. And the temperature at which they're exposed to the air gives you the different iridescent colors on there. Otherwise, it would be silver. Oh, I gotta find them. So tiny here. Ah, here they are. There are some garnets. Garnet is the poor man's ruby. These are a gemstone that looks like this in the wild, and you can see these embedded into rocks here in Ohio. I have found some in Morrow County. And when you get them out of the rock, they're a very hard mineral, and they can be shined and polished up and made into jewelry. And then over here we have our fluorite crystals. Oh, that's the back side of them. Here's some fluorite crystals. These are iridescent fluorite crystals. I've got one in my hand. If I can hold it up, it's a little bit easier to... so you can see that it comes in purple, and there's a nice big purple crystal, but behind it is more of a metallic, iridescent kind of a fluorite. There's another purple one. There's another tiny purple one. When I went on a rock hunting expedition with our Rock Nerd Club, we were in Stone Quarry up in northern Ohio, and they were mining for limestone, but we were finding little pockets of this, and I was not very good at finding this, but my friends were, and they found some big, beautiful collectible crystals, and they gave me these lovely little chunks that they considered to be more of a waste product, so that I could show them to you, because I think they're beautiful.